Morning to everyone. My name is S. Divakar. I am from mechanical department. My assignment topic is electronic polarization. Electronic polarization. Introduction to electronic polarization. Electronic polarization refers to the displacement of electron clouds within atoms or molecules. This phenomenon occurs when external electric field is applied to a material. Understanding electronic polarization is crucial in materials science and matter physics. See the diagram. Atomic model of electronic polarization. Definition of electronic polarization. Electronic polarization is characterized by the shift of the electron density relative to the nucleus. This shift creates an induced dipole moment within the material. The strength of electronic polarization depends on the nature of the material and the strength of the external field. Mechanism of electronic polarization. When a external electric field is applied, electrons in atoms are displaced. The degree of displacement varies with the atomic structure and the external field's intensity. This creates localized dipoles that contribute to the overall polarization of the material. Factors influencing electronic polarization. The polarizability of a material is influenced by its atomic or molecule structure. Larger atoms with more loosely bound electrons typically exhibit a greater polarization. Temperature and frequency of applied electronic field also impact polarization effects. In this diagram, innovation factors, managerial factors, environmental factors, organizational factors. Types of polarization. Electronic polarization is one of several polarization mechanisms, including ionic and dipolar polarization. Each type of polarization contributes differently to the material's overall dielectric properties. Understanding these distinctions helps in tailoring materials for specific applications. Measuring electronic polarization. Various techniques exist to measure electronic polarization, such as dielectric. These measurements provide insights into the dielectric constant and laws of materials. Accurate assessment of polarization is essential for applications in electronics, optics. Role in dielectric materials. Electronic polarization significantly contributes to the dielectric properties of materials. It enhances the material's ability to store and dissipate electric energy. Dielectric materials with the high polarization are crucial in capacitors and insulators. Unpolarized applications of electronic polarization. Electronic polarization plays a vital role in functioning of capacitors and transistors. It is also essential in developing advanced optical materials and photonic devices. Understanding polarization mechanisms aids in material designed for energy storage applications. Electronic polarization or orientational polarization, ionic polarization. Comparison with other polarization types. Unlike ionic polarization, electronic polarization occurs at a much faster time cycle. Dipolar polarization involves the orientation of permanent dipoles with electronic relays on electron cloud displacement. Each type contributes uniquely to the overall dielectric response of materials. Challenges in studying electronic polarization. Accurately modeling electronic polarization can be complex to the quantum mechanical effects. High frequency electric fields may lead to difficulties in observing polarization effects. Researchers continually seek methods to better understand and quantify this phenomenon. Future direction in research. Future studies will focus on the relationship between electronic polarization and nanostructure materials. Research in this area aims to enhance the performance of electronic and photonic devices. Innovations in measuring measuring techniques may lead to a deeper understanding of polarization dynamics. Conclusion. Electronic polarization is a fundamental concept is understanding material behavior under electric fields. Its implications in technically technology and material science highlight the importance of ongoing research. A comprehensive understanding of electronic polarization can lead to advancements in various applications. References. Introduction to Dielectric Materials by Smith. Polarization Mechanics in Materials by Johnson 2012. Advanced Electric Spectroscopy Techniques by L. Thompson 2023. Feel free to modify part presentation. Thank you for giving this opportunity.